we have the graph in red there of y equals x minus 1 squared plus 3. Question first says, determine 2 ways to restrict the domain so that its inverse is a function. Okay, right now, if you reflected this over this line, if you switched all of your x's and y values, just going to do it quickly here. Instead of having 1 comma 3, I would have 3 comma 1. Instead of 2 comma 4, I'd have 4 comma 2 and 4 comma 0. The parabola, if you reflected it over that line, would look like this. And I hope that you can see that that blue graph does not pass the vertical line test. And we should know this by looking at the original graph. If the original graph doesn't pass the horizontal line test, the inverse graph won't pass the vertical line test. So what they're saying in this question is, can we restrict the domain so it passes the horizontal line test? Like if I erased part of the parabola, how much would I have to erase so that I could pass the horizontal line? Does it make sense that if I erased half of it, then it would pass the horizontal line test? That's what we're going to do. We're going to, first of all, I'll put a title here, 2 ways to restrict domain of, and we're restricting the domain of the original equation. We could take the left half. If you took the left half, we agree that you could take everything less than or equal to 1. I'm going to put a purple box around that and highlight that part of the graph in purple. Okay. Or 2, I could have taken the other half. X is bigger than or equal to 1. I'm going to highlight that in orange. If I either took the purple half or the orange half, it would pass the horizontal line test. Putting both halves together doesn't pass the horizontal line test. On these questions, they say, what are 2 ways to restrict the domain? You're thinking about your original graph, and does it make sense that this is the important point? And the x-coordinate of your vertex will be where your domain is going to switch. So if I move the parabola around, my domain restrictions would move around as well, but it's going to be that x-coordinate of our vertex that's going to be a key thing for figuring this out. Then, it says write the equation of the inverse each time. So when I flip this over, the orange part is going to go here. The purple part is going to go here. We need to write an equation of those both times. Well, algebraically, you can find the inverse equation by switching x and y. So I start by, instead of writing y equals, I write x equals. I get y plus 1, y minus 1 squared plus 3. I think about getting y by itself. Y is inside this squared. So first I'm going to get that squared item by itself. And after I get that squared item by itself, I can get rid of the squared by square rooting both sides. And when I square root both sides, I have to remember plus or minus. And to get y by itself, I'd have to add 1 to both sides. This plus or minus gives actually two different equations. Sometimes it's nice to write them separately. One of them is going to be with the plus, and one of them is going to be with the minus. Okay? Use a graph to illustrate each way. So one of the things I want you to find out here is the top one go with the purple, or is the top one go with the orange? Does this bottom one go with the purple, or does the bottom one go with the orange? Okay. So we can think about our graphs, right? You see there you have two square root graphs. Both of these square root graphs get moved 3 to the right and 1 up. Do you see that both the orange and the purple square root graphs got moved 3 to the right and 1 up? Because this point right here is at 3, 1. One of those square root graphs has had a vertical reflection. A vertical reflection is when you have a negative outside the function. So does it make sense? Here's my one. I have a negative outside the function. That would have flipped my square root graph down. That match. Hold on. Wow, I got color coded wrong. That would have matched up with the bottom, right? And the bottom matches up with the purple graph. And so that makes this one go with the orange graph. So this equation goes with this domain restriction. This equation goes with this domain restriction. I find like you'll get questions like this on take-home quizzes and on your test. I find that color coding something like this is really helpful because you're going to have to do the domain restriction. I think on your test, I even give you 2 graphs so you can do it separately. Highlight the purple side, draw the purple graph that goes with it. Highlight the orange side, draw the orange graph that goes with it. I put an orange box around the equation of the orange graph. I put a purple box around the equation of the purple graph so that I could label each of them. This work that I did here in black, that actually is for both. I had to find the inverse. That's going to work for both of them. And circle questions 10 and 12.